Hey guys, in this video we're going to be covering all the questions for KC4. So looking at a number, 35. Our first question says, the graph models Yoshi's trajectory when jumping. So determine the maximum height. Now the first thing is you need to figure out where that highest point is. And it is right here at 4, 5. But since it's asking for just the height, all I need is that y value. So the height is determined by whatever that y value is. So I just have to say 5 feet. Right? I don't need that vertex point. It's just at 5 feet. Next question, example number 36. It says the graph models the path of Mario jumping. Determine the total distance in feet that Mario jumped. Now, one thing that we need to remember is that you always have to subtract the end, and we're going to subtract the start spot. So where did he end? So he ended right here at 6. And we have to subtract where he started. So he started right here at the ground of 2. So 6 minus 2 is 4 feet. Notice that he wasn't at the ground at 0. He was probably just walking forward. And then once he read that 2 feet, that's when he actually jumped upward. So you have to do the start, the end minus the start. 37. The graph models the parabolic path of Mario's fireball. Determine the initial height. So initial means the start. So where did the fireball start? So this is whenever the time, or whatever the x-axis, so I'm actually, it could be when time equals 0, or you can think when x equals 0. So this is the x-axis. So in this case, it is our x right here. So when time is equal to 0, my initial height is at 4. So this is going to be at 4 feet. Target B. Determine the approximate interval where the profit is. So interval is just between which x values, right? So think of interval as x values. Where profit means that it is above 0. So this is whenever it's going to be positive. Our profit then is going to be right here from 0 to a little more than 200. It's asking us, oh, not just profit. We want to look for increasing. So increasing is where our graph is going up. So it is going up until we get to this vertex point. So between which x values? That's going to be from 0 to 100. It is increasing. So 0, 100, it is going up. Then where is it going down? Well, my vertex point all of a sudden switches direction and my parabola is going down. But again, I only need the x values. So this is going to be from 100 until 200. Well, it's a little bit past 200 actually. So it's probably like 20, like maybe 210 or something like that. So let's go ahead and say from 100 to like 210. That's fine. All right. Where in the interval is the seller earning a profit? So by earning a profit, this just means above 0. So where is it positive? All right. Now it becomes positive right here from 0. And now I do see that my graph is increasing. I'm making the most money. My profit all of a sudden starts to decrease, but I'm still making money, right? So it's wherever it's above that x-axis. So here we're going to say from 0 to 8 is where I'm making profit. All right. Going ahead and moving on to number 40. In the context of the image below, explain the meaning of the domain. So kind of, what do we have here? So Angry Birds. We have this launch, right? And so our domain is whatever the x-axis is. So this could be the distance that the bird traveled. We can also say it was the time it took to launch. From the time it was launched to the time he hit the ground. It's whatever could be measured on that x-axis. So you can think of the distance traveled horizontally, or what we could say is the time it took for the bird to hit the floor. Either option is correct. You just have to make context of whatever that x-axis can be. Because again, domain is our x values. So what would make sense to put on the graph? Doesn't make sense to say how high it went, right? Because that would be measured on the y-axis. So target C, between which two coordinates is the average rate of change 6? So a couple things here. This is positive. So if it is positive, we need to look where the graph is going up. So the only places that the graph is going up is right here from this vertex point, and it's going up on this half of the parabola, right? So that's the only points there that I can actually choose. So by going up 6, that means I'm going up 6 over 1. So let's go ahead and just try to map out what some of these points are. So from this point, if I went up 6, let's see if I make the other point. 1, 2, 3, 4, 5, 6 over 1. That doesn't get me to a point. Let's try starting from this point. If I go up 6, 1, 2, 3, 4, 5, 6 over 1. That one does work. So I have to use these 2 points. So that first point looks like it's going to be at 0, what was that up at? 1, 2, 3, 4, 5. And over 1 up 11. And again, the average rate of change came from that slope formula. So remember when you had to subtract the y's, so 11 minus 5 over 1 minus 0. So 11 minus 5 is 6, 1 minus 0 is 1, and that is where we got that answer, like positive 6. Okay, so just to reiterate where that actually came from. All right, number 42, determine the average rate of change between -2 and 2. So again, these are the x values, and we have to figure out where our y's are. So at -2, I have a point here at 5. So that's 1 point. And then at +2, that is at -3. So 2, -3. So from here, we do our slope formula. So to find our average rate of change, we're going to take our y value and always subtract the other y value all over this y value, 2 minus a -2. 3 minus 5 is going to give me a -8. And 2 minus a negative is going to change to plus a positive. So that will be a +4. And -8 over 4 is going to simplify to a -2. So that is my average rate of change between -2 and +2. The function models the path of the eagle descending for food. Which interval represents the greatest acceleration? So here I'm looking for whenever I have the biggest number. So looking at here, what's nice is that it's already kind of labeled for me, right? This one goes up 1 over 1, so we notice here that this is 1. This goes up 3 over 1, so this is going up by 3. And this is going up 5 over 1. So where is the biggest acceleration? That would be that acceleration of 5. But if it's asking you for the interval, interval means x values. So I don't need to write that ordered pair of 2, 4, right, and 3, 9, x values. Between which x values did that happen between? Well, it happened between 2 and 3. So I just have to say between 2 and 3. And again, it's because those points were 2, 4. That's where I got that 2 from. And this one was at 3, 9. That's where I got that 3 from. So again, x values, I only have to say the x values. Alright, last couple questions here on target D. The fountain that is 13 feet tall sprays water into the air with an upward velocity of 9 feet per second. Write the function that gives the height h of the water in t seconds after it is sprayed upward with the initial height c. If there are no additional forces acting on it, our vertical motion model is as follows. So remember that we don't change anything unless we have the velocity and where it originally is starting from. So I'm going to rewrite that h of t, make you dizzy while I do it. So this is going to give me negative 16t squared plus, what is my velocity? What is it moving up by? Velocity also has a unit of distance over time. So this is going to give me that 9t plus what it was initially starting at. And how far did it start up in the air? Well, it was 13 feet tall. So that's where I'm going to put that plus 13. Alright, so the rectangle in number 45 says the rectangle has side A with an unknown length. So we don't know what the length is. If side B is 9 inches less than side A, create a quadratic equation that calculates the area. So the first thing is I am going to draw my rectangle. We have side A with unknown length. So we don't know what the length is. But the side B is 9 inches less than side A. So that means this is going to be my width. And if we don't know what the length is, I'm going to say that's x. And if the width is 9 inches less than that side, that means it's going to be whatever the side of the length was, which was x. I want 9 less than that. So I am going to subtract it. Remember that the area of a rectangle equals length times width. So setting up our equation would be area equals our length, which is x, times our width, which is x minus 9. Number 46, a ball is thrown straight up from 5 meters above the ground with a velocity of 9 meters per second. Gravity pulls it down, changing its speed by about 5 meters per second. Create the quadratic equation to model its situation. So for 46 here, we have that same setup. We are going to start with what we have in our equation of h of t equals negative 5t squared. We don't know what the time is, but we do know what the velocity is. Our velocity here is going to be 19 meters per second. So I'm going to plug in that 19t. And where was this starting up? Well, it started up at 5 meters in the air. So that plus 5 is going to be my c. Oh, nice. So plus c. Alright, and I believe that brings us to the end of our review packet. And that's the end of KC4. So good luck, guys. You have all your notes, your activities. Now you have the final review packet, so you have everything you need to ace this final. Good luck.